We think of Albert Einstein as the definition of genius, right? The guy who figured out the universe. But what if I told you he made a mistake? A really big one, and it took the world of physics almost 50 years to definitively prove him wrong.
It all boils down to this one famous phrase. And trust me, he did not mean it as a compliment. This was Einstein's way of dismissing a part of quantum physics that was so strange, so utterly bizarre, it just broke his entire picture of how reality was supposed to work. So, that's the mystery we're going to unravel today. This is a story about a massive clash between two of the most important theories in all of science, and really a fight over the very nature of the universe itself. All right, so to really get this, we have to start at the beginning. We need to understand the universe as Einstein saw it, the beautiful, elegant, and orderly cosmos that he himself described. Back in 1905, Einstein drops his theory of special relativity on the world. And it's all built on these two core ideas. They sound simple enough, but believe me, the consequences they have for space and time are just mind-bending. Now, that second principle, that's the one that really matters for our story today. The speed of light, which we call c, isn't just some random number. It is the absolute, final, unbreakable speed limit for everything in the universe. Nothing, not an object, not a piece of information, not a signal, can go faster. That's it. Full stop. And because of that universal speed limit, Einstein deeply believed in a principle called locality. And honestly, it's just common sense, right? For one thing to affect another thing, it has to either be right there next to it, or it has to send some kind of signal, a signal that can't travel faster than light. For Einstein, reality had to be local. There was no other way. But then along comes quantum mechanics, this whole new theory for how the universe works on the tiniest scales. And it didn't just seem to bend Einstein's rules. It looked like it was snapping them right in half. And right at the heart of this conflict is this thing called quantum entanglement. Okay, picture this. You have two particles that are fundamentally linked together. You can pull them apart a few feet, across a city, or even across the entire galaxy. The moment you measure something about one of those particles, you instantly know the same thing about its partner. Instantly, no time delay, faster than light.
So you can see the battle lines being drawn here. On one side, you've got Einstein's universe. It's orderly, it's predictable, effects have local causes. But on the other side, you have this quantum reality, which suggests the universe is connected by these invisible, instantaneous threads, where things don't even have definite properties until you look at them. And that was the spooky action at a distance he just could not get on board with. So what did Einstein do? He didn't just sit back and complain. No, he set out to prove that quantum mechanics had to be missing something, and he did it by coming up with one of the most brilliant thought experiments in the history of science. He teamed up with his colleagues Podolsky and Rosen, and they came up with what's now called the EPR paradox. It goes something like this. Imagine you create two of these entangled particles, and you let them fly off in opposite directions. After they're miles and miles apart, you measure something about particle A, and because they're entangled, boom, you instantly know the state of particle B. Okay, so here's Einstein's big gotcha. He said, look, you never touched particle B. You never even looked at it. So how could your measurement of particle A possibly have created its properties? He argued the only explanation was that the properties were already there, written into the particles from the very beginning. He called these hidden variables. And since quantum mechanics didn't account for them, it must be an incomplete theory. And this quote just perfectly captures his whole problem with it. To Einstein, reality was real. The moon is obviously still there even when no one is looking at it, so a particle's properties should be too. He just refused to accept a universe that only decides what it's going to be when we observe it. Now, for decades, this was pretty much just a philosophical debate. You had Einstein's hidden variables on one side and quantum weirdness on the other. There was just no way to actually test who was right. Until technology finally caught up with the theory. It took almost 30 years before a physicist named John Bell figured out a way mathematically to put Einstein's idea to a real test. Then, it took another couple of decades before a French physicist, Alain Aspect, finally had the tech to actually run the experiments. A 50-year-long debate was finally going to get an answer. And the verdict? It was crystal clear. The universe really is that spooky. The experiments showed that the connections between these entangled particles were way stronger than any theory with hidden variables could ever explain. On this one crucial point, Einstein was wrong.
This is maybe his most famous quote, right? It shows his deep gut feeling that the universe should be deterministic and predictable. But it turns out the experiments showed that on the quantum level, the universe absolutely plays dice. The results aren't predetermined at all. They're fundamentally random.
So, what does this mean for Einstein's legacy? Does this big mistake somehow tarnish the reputation of one of history's greatest minds? Well, not exactly. In fact, it might just make his story even more compelling.
I mean, let's be real, this wasn't his only so-called blunder. He pushed back against huge parts of quantum theory his whole life. He spent the last 30 years of his life on a search for a unified theory that just didn't pan out. He was, after all, human. But let's put that into perspective for a second. This is the same guys who gave us special and general relativity, E=mc², the work that won him the Nobel Prize, and he predicted gravitational waves 100 years before we could actually find them. His successes didn't just change science, they literally shaped the modern world. And that really gets us to the most important takeaway here. Einstein's stubbornness, his refusal to accept this spooky action, it wasn't a failure. It was a gift. His sharp questions and brilliant challenges forced the next generation of scientists to get serious. He basically dared them to prove that reality was as weird as they were claiming. And by rising to that challenge, they deepened our understanding of the cosmos in ways that might never have happened otherwise. Which kind of leaves us with one last thing to think about. What's actually more valuable for science? Is it a brilliant, profound question that turns out to point in the wrong direction? Or is it a simple answer that just happens to be correct? If you ask me, Einstein's legacy proves it's the brilliant question, every single time.